Hello everyone, this is Alice Gao. In this video, I'm going to talk about two things. The first one is what are some challenges that we might encounter when we learn a decision tree given a data set. And second, I will show you an example of constructing a decision tree given that we know an order of testing the input features. Let me talk about the challenges first. So first of all, how should we build a decision tree in the first place? In other words, what kind of information do we need when we build a decision tree? Well, the first information we need is that we need to decide on in which order we will test the input features. Let me go back to the Jeeves data set to explain this. So here is the training set for the Jeeves data set, and we have, if you look on the left hand side, we have 14 examples. So each row is corresponding to an example, and for each example or for each data point, we have the values for 5 input features. Actually, day is not going to be a useful input feature. So really, we only have values for 4 input features: outlook, temperature, humidity, and wind. Then we have 1 target feature, which is whether Birdie decided to play tennis or not. So what I was saying is that we need to decide on in which order are we going to test these 4 input features. Should we test outlook first or temperature first? So on and so forth. And once we decide on an order, it is straightforward to grow a tree. So coming back to this slide, once we decide on an order of testing the input features, how do we grow a tree? Well, at each test, we're going to take the examples that we have at that point and then split up the examples based on the value of the input feature in each of the examples. So I will show you the process in a minute. All right, so this is the first question that we need to consider. And turns out the basic information we need is an order of testing the input features. The next question, which decision tree should we generate? And first of all, the reason we need to ask this question is that given a different order of testing the input features, we will get a completely different tree. So you might be wondering how many possible trees are there? Turns out a decision tree is a very, very powerful model in the sense that it can represent any discrete function of input features. And there, given a set of input features, there are a lot of such discrete functions. If you want, take some time to think about this. You can use a counting argument to calculate, given that there are n input features, how many possible decision trees can you generate? Now, given this, we need to make a decision. Which decision tree should we end up generating and why? I've broken this down into 2 more specific questions for you. So the first question we should ask is, well, previously we said that given an order of testing input features, each order will give rise to a tree. So what order should we use? Turns out this is a difficult question. Finding the optimal order, finding the best order for testing the input features is actually a very difficult problem. And also, the search space, just the number of possible orders, is quite large. So given this, we are going to use a strategy which is called greedy or myopic search. So in short, this strategy says that we are not going to try to find an optimal order. But every time we need to test an input feature, we will take the best decision, we will make the best choice at that point. So the difference between the two is that if we want to find the optimal order, we might need to look into the future. We might need to consider, if I choose to test this feature right now, then going into the future, how might this affect my choices in the future, and would that give me an optimum tree? But we're not going to think about the future. Instead, we'll just think about what is our best decision at that point. So that's why it's called greedy or myopic. Myopic means not future looking, not forward looking. All right, so this is the first question we will consider. And then the second question we'll consider is that even if we are given an order of testing the input features, it does not mean that we need to grow a full tree. In other words, at every branch in the tree, we do not have to test all the features. Why should we? Right? So now the question is, should we grow a full tree, or should we stop somewhere earlier? Maybe having a smaller tree is better. Right? Think about overfitting that I talked about in the introduction unit before I start talking about decision trees. So this question, to answer this, turns out we need a bias. We need to make some assumptions. And one assumption we can make is using the Occam's razor principle, which says that the simplest model, the simplest hypothesis is probably the best. So one heuristic we can use is that let's prefer the smallest tree that we can generate. So what does that mean? Well, we still have a couple of options. We could prefer the shallowest tree, the tree that has the least depth, or we could control the number of nodes we actually have in the tree. Right, so we could choose to generate the tree with the fewest nodes. So here are some examples, basically things to think about. Now I'm going to discuss the question, the answer to big question 2 or small question 2 and 3 later. And now let's look at, if we're given an order of testing the input features, how do we generate a full tree given that? Here I have given you an order of testing the input features. First, we'll test Outlook, and depending on the value of Outlook, we might decide to test different features. And also for all other branches and for all other remaining features, I've specified the order. So this order is sufficient for you to generate a decision tree without ambiguity. This is a good point. You haven't seen an example, but this is a good point to pause the video and try to generate the decision tree yourself. The process is quite intuitive. Take the examples, split them up depending on the values of the input features. And then if you get to a point where all of the examples are in the same class, then you just need to label it and then you're done. But in a moment, I will show you how to generate this decision tree. Let me show you how to construct a decision tree using the training data from GST-Valet. Unfortunately, it's difficult for me to show you the training data and the tree at the same time. So I hope you open the training data in a separate window so that you can follow along. Our order suggests that we will test Outlook first. So this is going to be the root of our tree. Outlook has 3 values: sunny, overcast, and rain. Notice that this is already an example where we're not doing Boolean test because this feature has 3 values. So we'll have 3 branches: sunny, overcast, and rain. It's going to be useful to classify our examples into yes or no, so positive and negative examples first. So let me do that before I go down any of the branches. So we have positive and negative examples. If you look at the training set, go through each example, and depending on the answer, you can put them in the right set. All right, so I've divided up the positive and negative examples. Now, depending on the value of outlook, I'm going to further divide them up into 3 sets. For example data point number 3 is overcast and it's positive, so I'll put it in the middle. Data point 4 is rain and positive, so I will put it right here. You can keep going like this. Now I've split up all the examples into 3 sets based on the value of outlook. Now we need to reevaluate and think about when can we stop growing the tree, right? We want to grow the tree to the full tree, but still, when do we stop? Well, we can stop if all the examples belong to the same class. So all of them are either positive or negative. At that point, we can make a decision, so we don't need to test input features anymore. Right? And luckily, this is already happening for the middle branch. When outlook is overcast, all of the examples are positive. So at this point, we can already label the node with a class, which is yes, Birdie decided to play tennis and then stop there. We're pretty lucky at the middle branch, but we're not so lucky elsewhere. So for Sunny and Rain, we have both positive and negative examples, which means we have to keep testing more input features. Based on our order of testing input features, on the left, we will test temperature. And on the right, we will test wind. Let me go to the left branch. So temperature has 3 values, hot, mild, and cool. We'll do the similar thing, have 3 branches, each label with the corresponding value, and then take the data set, which we have a set of 5 points, and divide them based on their value for temperature. So I've taken the 5 data points, 9, 11, 1, 2, and 8, and divide them up based on their value for temperature. Now again, we'll look at this and see, can we make a decision for some of these already? Well, sure, we can make a decision for temperature when temperature is hot. That's just no. We can make a decision for when temperature is cool, and that's yes. But for the middle branch, we still have 1 positive and 1 negative example, so we need to keep branching. And based on our order, next we will test humidity before we test wind. By now, you should get the basic idea of this algorithm. If we know in what order we're testing features, then at every step, we're simply splitting up the examples based on the value of the feature. And then if for each branch, for a branch, we're left with all of the examples in one class, then we can make a decision there and stop. If not, then we have to go on and test another feature. Let me complete the tree for you. To check your understanding, it would be a good idea for you to complete the tree yourself and then check the answer in the video. This is the complete decision tree. This is the full tree that we would grow to if we don't stop in the middle. I hope you got the same one. If you didn't, let me know. Maybe I made a mistake. I hope not. So when constructing the decision tree, I told you that we can stop whenever all of the data points, the examples, belong to the same class. This is true, but we are dealing with a simple example right now where this is the only stopping criteria we have. It turns out there are 2 other slightly more weird stopping criteria that we can run into. Another one is there could be a case where we run out of features to test. And a final one is that there could be cases where we go down one branch, so we decided to take a value for a particular feature, and then we discover that there are no more examples left. So in the next video, I'm going to talk about these 2 weird cases. Let me summarize. After watching this video, you should be able to do the following. Explain 3 main challenges we have when we learn a decision tree given a data set. Then be able to construct the decision tree given an order of testing the input features. Explain when should we stop when we're growing a full decision tree. That's everything. I will see you in the next video. Bye for now.